So this week I will be going over the important rules we have learned in the last week and a half. To start, I will start with the power rule, and important things to know about the power rule. If you see a square root of x, you can automatically look at that as x to the 1/2 because the square root is to the 1/2. If it was a cube root, it would be to the 1/3, x to the 1/3. So basically what you do is if you see an x to the 1/2, you put the 1/2 as the coefficient in front of the x, and then you subtract 1 from the original power. So it'd be 1/2 minus 1, which is a negative 1/2. So it'd be 1/2 x to the negative 1/2. Then here's another example is of an equation. G of x equals x to the third plus 4x squared plus 6. So for that, you would, again from above, your coefficient would be 3, it would be 3x, and then you subtract 1 from the original power, so it would be 3x squared, and then plus, when there's a coefficient already there, you multiply the coefficient by the original power, which would be 4 times 2 is 8, so it would be 8x, then you have to subtract 1 from the original power, which would be 1, so it would be 8x, and then if you ever see a number just alone without an x or a variable, it's always 0. Next, for f of x equals x plus 5 squared, you have to expand that first, and then you do the same thing above, as I did above. Then you have the e to the x rule, which is probably the easiest rule because it stays e to the x. When you differentiate it, it's just e to the x, so it doesn't matter what's in front of it. It's just going to say if it's 10e to the x, it's going to be 10e to the x for the differentiation. Key things to know is the a, what's in front of the x or our variable, is our constant variable, and that our constant variable could be in the power or the coefficient place, and it acts as a number. Then when we're given we're told to put our new differentiated value into equation, we have to know when we're using a tangent line, it's just the regular slope. It's whatever you get for the slope. But then if you're asked for the normal line, you have to take the inverse of that slope and the reciprocal and the inverse of the slope. And you're always doing that as point slope form. Now we have the product rule. There's no real set equation for it because since you're adding, it could be f of 1 of g plus g of 1 of f, or as I have here, it's f of g of 1 plus g of f of 1. You can kind of play around with that. You can kind of see how I did this. So our original equation is x to the third e to the x, and we split that up into two equations. It would be x to the third and e to the x. So you have your f of x is just your x to the third. That's your first function, and then you're multiplying it by the derivative of your g of x, which is derivative of e of x, just e of x would be times e of x. Then you have to add. You have your regular g of x, which is e to the x, and you have to multiply that times the derivative of the f function, which is x to the third, which would be 3x to the squared. And you do that, you multiply it out, and this is what you get for your answer. So now we have this is just another example of the product rule. Again, remember, if you see square root of x, that's automatically x to the 1/2. Now you get your quotient rule. Now this equation is exactly how it should be whenever you're doing it. Unlike the product rule where it can be kind of jumbled up. It's y prime equals g of x times the derivative of f of x minus f of x times the derivative of g of x divided by g of x squared. Now, when we're doing that g of x squared, we usually don't expand that. We just keep it how it is. So our first example is 3x plus 5 over 2x minus 6. So you take your g of x function, which is 2x minus 6, and you multiply it by the derivative of your fx function. The derivative of 3x plus 5 is just 3. So you multiply that out. You have to subtract your f of x, which is 3x plus 5, times the derivative of g of x, which is 2 of the 2x minus 6. And then you divide it by, you square your g of x function, which is 2x minus 6 squared. And then you multiply all that out, and the 6x and the negative 6x cancel out, and then you add your negative 18 plus negative 10, and you get negative 28, and all that is over 2x minus 6 squared. Remember, do not expand the 2x minus 6 squared. Now, our newest rules are the differentiation rules. You can do math to get all these, but we need to memorize them. So, sine of x will always be cosine of x. Cosine of x would be negative sine x. Tangent of x would be secant squared x. Cotangent of x would be negative cosecant squared x. And secant x equals secant x times tangent x. And cosecant x equals cosecant x times cotangent x. Now, on the first day, we learned how to do the derivative of, for example, sine of x, and we got cosine x. There's a lot of math to it, but thank God all we have to do is memorize them, which is kind of nice. And that's what I learned this week. Thanks for listening.